Hello, everyone. I almost said good morning because I'm recording this in the morning, but you guys could be watching this at night or whenever. I don't know. Okay, we are going to be looking at sequence of rigid transformations today. A sequence is when we put more than one transformation together. So you can look at this one here, for example, and it looks similar to a reflection. But if I was to reflect this down, it would not be over here. So, we're going to just be learning how to identify and describe sequences and making sure that when we are describing them, we're including more than just one and that we're doing it in the right order. Sometimes there's a specific order, sometimes there isn't. Um, so one of the things that I use with sequence of transformations is this thing called patty paper. It just looks like a piece of parchment paper. It's also called deli paper because this is what they wrap your sandwiches in. But it is kind of see-through. And so that's why we use this. So what I like to do with this is I like to trace my original shape on top of the patty paper. And then I move the patty paper around to see um, how I can fit it on top of the other shape. So I said that this looks like a reflection. So if I'm reflecting it, I'm going to flip my patty paper over. And then a reflection would put it approximately right here. And then I would still need to slide it over. So this figure was reflected and then it was translated. So notice it was reflected over our x-axis. So first figure one was reflected over the x-axis. Then we said we had to slide it over. Well, like always, when we talk about translations, we have to identify the direction and distance. So if it was here after the reflection, I would need to move it 1, 2, 3 units to the right. And if you don't understand like the patty paper or if you struggle with using it, you can always draw this reflection. So this shape here, this point is 1, 2, 3 away from the x-axis. So it is 1, 2, 3 away from the x-axis over here. This point is also 1, 2, 3 away from the x-axis. So it's 1, 2, 3 away from the x-axis over here. This point up here is 1, 2, 3, 4, 5, 6 away. So it's 1, 2, 3, 4, 5, 6 away over here. And then this point is 1, 2, 3, 4, 5, 6, 7, 8 away. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8 away over here. So here's what the shape looks like after the reflection. And I can see that if I want to move it over so that this point moves over to this point, I have to move it to the right 1, 2, 3 units. So I would say it reflected over the x-axis, then it was translated 3 units to the right to become figure 2. And there's no period at the end. There should be a period at the end because it's a complete sentence. Okay. So number 2 here, I'm going to do the same thing. This time, however, because it is a isosceles triangle, so my side AB and my side AC and my side A prime and B prime, A prime and C prime, they're the same length. So I am going to label my points as well. So I'm going to do A, B, and C. That will make a difference on this one because this looks like it's just been rotated 180 degrees. Well, if I use my patty paper and I rotate my patty paper 180 degrees, sure, it matches up, except for the fact that my point C is where B prime is, and my point B is where C prime is. So it is actually not a rotation. So what I actually want to look at is how can I line up so that C still stays on this side when the triangle is pointing down. Well, I want to do that by, again, flipping my paper. And now notice I have C on this side with A pointing down. So again, I have reflected it over the x-axis, and I'm going to have to translate it over again. So I am going to draw my reflection. So C is 1, 2 away. So C prime is 1, 2 away. B is 1, 2 away. So B prime will be 1, 2 away. And A is 1, 2, 3, 4 away. So it'll be 1, 2, 3, 4 away over here. So this is what it looks like after the reflection. So first, A, B, C was reflected over the x-axis. Then I need to translate it. So I need to just slide this over so that A matches up with A. So that's going to move over to the left. And it's going 1, 2, 3, 4, 5, 6 units to the left. So then translated six units to the left. But like I mentioned, sometimes there's more than one way to do it, or maybe the order doesn't matter. So 3 here says there were 2 possible answers for number 2. Write another one below. So if I'm looking at this, if I was to translate it 6 units to the left first, and then reflect it over the x-axis, that will also match up. So this is an example where it does not matter the order in which you do the transformations. So I can say first triangle ABC was translated 6 units left, then reflected over the x-axis. Oops, did not mean to put period there, to become A prime, B prime, C prime. This does not always work, so it is very important to keep in mind and be mindful about the fact that sometimes you can reverse the order and sometimes you can't. Okay, so 4 is kind of tricky, but it's a really good one to get you thinking. It says coordinate Q is at 3, comma, -4. It is reflected over the y-axis, then translated 3 units up to become Q prime. What is the coordinate of pair Q? So this is not giving you the graph, but you want to think about what the transformations do to the points. So like I said in the video on Monday, when reflecting over the y-axis, the y-coordinate stays the same, the x-coordinate becomes its opposite. So Q would become, that should be a Q, not a lowercase a. From my, again, the y would stay the same, so my x would become opposite, my y would stay the same. So for this example, my x is 3, so my opposite of 3 is -3, and my y stays the same. So that is the point after the reflection. Then it was translated up 3 units. Well, up affects the y coordinate because of the y-axis goes up and down. And if it's going up, we add 3. So now I want to look at this and take my new x and y, but add 3 to my y. So my x will stay the same, -3. -4 plus 3 will become -1. So this new point is -3, -1. And if you're ever not sure, you can always just try to like draw yourself a little graph or use a graph that you see. So if I was to come up here and use this graph, I have a point at 3, -4. So if I go over 3 down to -4, that's actually where point A is. So if I reflect it over the y-axis, that's over this way and become where this A is. And then up 3 units, it would move up 1, 2, 3. And notice that that point is at -3, -1. Okay. So here is a PARCC practice problem. PARCC is the test we used to take before MCAT, but basically it's saying it's the same level as an MCAT practice problem. So it says which figure can be transformed into figure P, so figure P is this one, by a translation 2 units to the right, followed by a reflection across the x-axis. So I want to kind of go backwards. I'm looking at P, and I am going backwards in this problem. So instead of going 2 units to the right, followed by a reflection across the x-axis, I'm going to reflect across the x-axis first, and then I'm going to go 2 units to the left. So if I reflect across the x-axis, oops, I forgot that when I use patty paper and reflections, I want to draw my axis I'm reflecting over. So I'm reflecting it over here, and then it's going 2 units to the left. That matches up with figure M. Then it says which figure can be transformed by figure into figure L by a rotation followed by a translation 2 units down. So this one does not say how far it is rotating or the direction it is rotating. But luckily we want to do that true translations up first in order to because we're going backwards. So here is my shape L. I'm going to go 2 units up. So 1, 2. That then puts my origin here. Now I want to reflect it. I'm just going to keep I'm going to rotate. I'm just going to keep rotating it until it matches up with something. So it's not M. It's not N. It almost looks like P, but it matches up here with J. So figure J is a rotation. I can rotate J and then move it, translate it 2 units down to match up with L. A couple things while looking at this, something that we're going to kind of get to and talk to more later on this week and moving on into the next unit as well, is we could kind of have crossed off figure K here and figure N if it was an option, because this is not the same size. And figure N is not going to match up either shape-wise. So these shapes here are all the same size. These ones are not. And because they're not, our transformations that we've been using would not work. Okay, if you guys have any questions about any of this, please be sure to ask me.